What we have here is a potentiometer, which is a large resistor which divides the positive 10 volts down to ground. So it's divided over a large resistor. Now, depending on where we can tap off the voltage from this resistor, we get different amounts of voltage. So for example, if I put a wire directly onto this part here, I would get the full 10 volts because the voltage goes straight through to this wire. If I had to tap halfway along this resistor, I would get about 5 volts, about half of the voltage, because some of the resistance reduces the voltage from the 10 volts, and some of the resistance is grounding the voltage. And if I had to take a wire at the bottom part here, really this is down to 0 volts. There's a lot of resistance above it and very little resistance down to ground. So a good way of viewing a potentiometer is you can have a tap which can take different parts of the voltage and output, or different parts of the resistor and output a varying voltage. So with a linear potentiometer, if it's at the smallest position, it would output 0 volts. As I move the linear position upwards, it would increase the voltage about 2.5 volts, about a quarter of the way. As I increase it up, we'd get about 5 volts halfway. Keep increasing, about 7.5 volts. Of course, this is all analog, so it would go 7.5 volts, 7.6 volts, 7.7 volts as it increases right to the top at 10 volts. So that's how a distance sensor can be used to measure distance and convert that into a voltage. It's just a slide as it slides up and down along this resistor. So I hope you like this low-tech version.